We have all visited the supermarket and found out the food is usually categorized as fruits and vegetables. Even though both types of food give us energy, there are some fundamental differences between them. Similarly, there are a lot of physical quantities around us. There is a need to categorize those quantities based on some fundamental difference between them. Joe is on his way to his friend Sam's house to attend his birthday party. But there is one problem. He doesn't know the location of his house. To locate the house, he looks into the hints given to him by Sam. Walk 200 meters from the bus stop on the main road. Take a turn and keep walking for another 100 meters till you reach the central library. In the building opposite to it is my house. Do you think these clues are precise enough for Joe to reach Sam's house? What is one factor missing in all of these? Yes, it is direction. Only when directions are specified along with distances like 200 meters towards left, turn towards right, etc., will Joe be able to locate Sam's house. Distance, when specified along with direction, is referred to as displacement. Just like displacement, in physics, there are several physical quantities that are incomplete without specifying the direction, called vectors. Then, there are those quantities which do not require direction, and only their numerical value suffices for them. These are called scalars. Let us learn to distinguish between scalars and vectors. To begin with, can you tell what the volume of this book is? Volume is a three-dimensional space that an object occupies. In this case, it is 2,800 cubic centimeters. This statement gives complete information about the volume of the object. Such quantities, which are completely specified by only a numerical value, along with its proper unit, are called scalars. Clearly, scalars have magnitudes only and no direction. Some of the common examples of scalars are temperature, time, speed, etc. Remember that scalars can be added, subtracted, multiplied, and divided according to the rules of algebra. Next, if we move the object up or down, left or right, we still have an object of volume 2,800 cubic centimeters, irrespective of its direction. However, the displacement of the same object with respect to some reference point O on moving it 5 meters in the upward direction is very different from what we get on moving it 5 meters to the right. This clearly means that the displacement of an object not only depends upon its magnitude but also on the direction. Such quantities which require magnitude as well as direction for their complete specification are called vector quantities. Some of the examples of vector quantities are force, velocity, acceleration, etc. Vector quantities are represented geometrically in two-dimensional as well as three-dimensional spaces as directed line segments or arrows. The length of the arrow corresponds to the magnitude of the vector quantity, while the direction of the arrow corresponds to the direction of the vector quantity. The tail of the arrow is called the initial point of the vector, while the tip of the arrow is called the terminal point of the vector. If the force vector F has the point P as its initial point and point Q as its terminal point, we can write Vector f equals vector pq. Scalars and vectors both can be represented using normal letters as their symbols. However, vectors are differentiated by either making them bold or by placing an arrow above the symbol. For example, vector f, vector w, and vector v represent the vectors of force, weight, and velocity, respectively. To qualify as a vector, a quantity having magnitude and direction must also obey certain rules of combination of vectors, like vector addition, vector subtraction, multiplication by a scalar, dot product, cross product, etc. We will learn about all these in our modules later on. To summarize, quantities that are completely specified by their magnitudes alone are called scalars, whereas those that require magnitude as well as direction to be completely specified are called vectors. Scalars are represented using normal letters as their symbols, whereas vectors are represented by placing an arrow above their symbols. Vectors are represented geometrically in two-dimensional as well as three-dimensional spaces as directed line segments or arrows. Scalars obey rules of algebra, whereas vectors obey rules of combination of vectors. There is an interesting quantity known as the displacement of an object. While playing ping pong, when the ball returns back to you, the total displacement of the ball is 0. There are some more interesting facts about displacement, so stay tuned to find out more.